spectroscopy. And what we're going to use is the Vernier SpectraVis Plus, which is a simple little unit here. Now this is only good for visible measurements. So that means wavelengths from about 380 nanometers up to about 850 nanometers. That's only for solutions that have a visible color. So this connection to the computer is real simple. We have this one line into a USB port, which supplies power and data transfer from the unit to the computer. And we're going to need, since this is a Vernier product, we'll need the Logger Pro software. So this will interface with the unit. And you should get a screen that looks like this. You've got wavelength versus absorbance. Let's get rid of using chart options. Do a right mouse click and we'll click this off and have a screen like that. So on the y-axis we have absorbance and wavelength here from, there's 400, 500, 6, 7, 8, 950 or so. So first off, let's go up to experiment, come down to calibrate spectrometer. And if the unit's been plugged in for a few minutes, you can skip the warm up, so I'm going to click on that. Now we're going to put a cuvette of water or appropriate blank into the spectrometer. The arrow is going this way, and you want to be sure not to put the frosted side that way, but in line with the arrow, the clear side. And we can say finish calibration. Give it a second here. It'll scan, store the average. Then we can say OK. And if we wanted to check that everything is reading 0 with the blank in there, we could hit collect. And we should get all zeros essentially. So the red line is the blank. Stop. Now as a check solution, we can dump this out. And I have a solution of almost 500 parts per million potassium chromate in water, in basic water. And these cuvettes hold about 2.5 to 3 milliliters. I'm going to put that in the spectrometer. And let's see what this looks like. Again, go back to collect. Let's choose store the latest run. So it'll keep the red line, which is our blank, and here's our solution, which absorbs. It's a yellow solution, so it's absorbing down near the purple end of the visible part of the spectrum. Since this is off scale, we can do a right mouse click, go to graph options, go to axis options, and come down here to the bottom is 100. Let's make this, say, a value of 2.0. Done. And now we can see the top of our peak. So there you go. So you have a visible spectrum from 382 all the way up to 940, almost 948. With a peak maximum at, if you put your cursor on the top of the peak, you can see here 400 nanometers, 400.2. The absorbance is 1.7. Now if we want to get a good estimate, a good measurement on this solution, you always dilute your concentrated samples so the maximum is less than 1. So we'd want to dilute that down, but for just illustrating this is fine. All right, so we'll stop that. All right, one other feature that we want to show here is we come up to this icon here, this graph with the rainbow colors, and click on that. You have 3 experiments that you can do here. We have, right now we're in absorbance versus wavelength, but when we do our enzyme kinetics, we will be looking at absorbance versus time, so that's going to be important. And then we have absorbance versus concentration when we're doing our protein assays, and we're setting up a Beer's law plot. So you're going to use absorbance versus concentration. Let's, for example, if we click on that, notice what it's done. It's checked, it's looked for the largest peak, the tallest peak, and it's highlighted that and checked that. So if you were going to do Beer's law on this solution, and that wavelength, this is the way you would set it up. Then we say OK. It says, do you want to store the latest run before switching collection mode? Answer no, we'll erase the data. So we're going to say yes. And so it keeps our original full spectrum data, and then below it, it sets up for the Beer's law experiment, which is absorbance, in this case at the maximum wavelength that we observed, versus concentration. Now this is in moles per liter, and it defaults between 0 and 1. If you would want to change that, you could click, left mouse click on concentration, and then it's going to open a screen such as here. I believe that is not correct. Let's go back here and click on that again, concentration. Okay. If we say more, okay. So if we go to concentration, let's do that again. So if we do concentration, more, it'll open this screen, Access Options. And you could select manual. The scaling is manual, and for example, you could make that from 0 to say 0.1 molar, because 1 molar protein concentrations are too high, and that would scale then from 0 to 0.1. So you have control over what this expanse is here. And then you could run your Beer's law experiment. So you'd put in the concentration of the blank and what the absorbance is, and so forth. You'd measure these. So that's your Beer's law plot. So let's stop that. For kinetic runs, we could come up here. We come up here to our configure spectrometer again, and we would choose absorbance versus time. Say OK. And the bottom screen then defaults to the absorbance at that maximum wavelength versus time. And again, you could click on that time, click on more, and you could change the scale. Instead of from 0 to 200 seconds, you could make it, say, 100 seconds, and so forth. So this is the basic screen here. You're using the Vernier spectrometer, and you're using the configure spectrometer for the 3 kinds of experiments that we want to do. So we'll stop there.